Welcome to our tutorial video, where we'll show you how to integrate hyperscanning tasks with BCI 2000. BCI 2000 is an open-source, multi-purpose software tool for real-time biosignal acquisition, processing, and feedback. Its adaptability allows it to support a broad spectrum of neurophysiological experiments, from simple stimulus presentations and neurofeedback tasks to complex interface experiments. Additionally, it is very easy to add peripherals such as eye trackers. BCI 2000 Hyperscanning introduces a multiplayer gaming architecture that leverages a central server to keep game states synchronized across several local clients in different locations, while also capturing and aligning neural and behavioral data from players. This setup facilitates research into brain-to-brain interactions and synchronicity among multiple participants. In a multiplayer game, all clients must know the game's current state. This is achieved by maintaining the game state through a collection of state variables within a state machine. Our system includes a master state machine hosted on a central server in the cloud, along with individual state machines for each client. Connections between clients and the server are managed via TCP sockets, ensuring consistent data transmission. When a client updates its state machine, the server records the new state in its master state machine and synchronizes the update across all clients. BCI 2000 Hyperscanning supports two types of multiplayer games, turn-based and live action. In turn-based games like tic-tac-toe, players take turns making decisions and performing actions within a set time frame. After a player completes their turn, the next player takes their turn, and so on until a specific condition is met to end the game. Unlike turn-based games, live action games don't have discrete turns. Players could interact with the game independently of other players. The gameplay is more fluid and dynamic, with actions happening in real time rather than taking turns. The server's role is to store, update, and distribute a master list of states, which ensures each client's state and stimuli are synced. You will need a Mac or Linux computer to deploy the server. Keep in mind, the server is not an instance of BCI 2000. It is a separate application that interacts with client instances of BCI 2000. We'll demonstrate server deployment on a Mac. First, go to the terminal or shell, and run the command shown to download the backend code from GitHub. Then go to the Hyperscanning directory by typing cd hyperscanning. Next, compile a project with make-b. And finally, launch the server with /application. Parameters are divided into shared and local categories. Shared parameters are synchronized between two clients to ensure that the same experiment is being run for each subject. Some example parameters are the stimulus sequence or the background color. The shared parameters should be stored on the server computer as a parameter file and sent to each client when it connects to the server. Thus, you will need to upload this parameter file to the server computer under /hyperscanning-backend folder. The local parameters are ones you want to customize locally, such as window size. The local parameter is stored on the local BCI 2000 computer, like a regular parameter file. The Hyperscanning application module functions similarly to a BCI 2000 application module, except that the Hyperscanning application module is inherited from the Hyperscanning application base class. This class adds server synchronization to standard operations like publish, preflight, and process, resulting in shared publish, shared preflight, and shared process methods. These methods behave in exactly the same way, except they also call the client loops which interact with the server. You can find the Hyperscanning application base source code under the path shown here. You can update the game states by writing state isReadyStart1 equal to 1, and you can get the value of the game states by assigning a variable isReady equal to state isReadyStart1. Declare game states in the batch file as follows, and this is appended next to the application module. We are using Signal Generator, which could generate a test signal suited for BCI purposes. For the application module, we are using the tic-tac-toe game for demonstration purposes. Double-click the batch file, press Config, and navigate to the Application tab. Scroll down until you see the Hyperscanning section. IP address is the IP address of the server computer, and the port is defaulted to 1234. Parameter path is the path to save the parameter file downloaded from the server. If you declare the game states in the batch file, you will see that the shared states column has already been filled. Client ID is ID for this client. Leaving it empty will set the client ID as the IP address of the client computer. Session ID is the ID for the game session. It must be the same between clients in order to play the same game. This ID is used to resume the game from where it was paused. In this case, we will input 5555 for both clients. For the rest of the parameters, you can keep them as the default values. After configuration setup, press Set Config and press Start. After the two clients push the Start button, we are ready to play the game. You now have the knowledge to implement BCI 2000 Hyperscanning in your experiments. For further questions, please consult the BCI 2000 wiki. Thank you for watching our video.